Hello, hello, hello. Good morning, good afternoon, and good evening, and welcome to Open Source Friday. We have a wonderful guest joining us today, Solomon Hykes, the founder, author, and maintainer of Dagger, and also former creator of Docker as well. So welcome to the show, and excited to have you join us today.
Thank you. Thanks for having me.
Today is going to be a really fun opportunity to just kind of learn a little bit more about Dagger and kind of the future of CI and what you're building. And I'm super excited to learn a little bit about the project, the community, and how you got there. So maybe just kind of a quick question to kick off the conversation. Can you give us a little bit about your background, kind of your journey into open source, and ultimately what inspired you to build Dagger on this morning?
Sure. So yeah, Dagger it's a startup, and it's also the name of the open source project that the startup is based on. And we're trying to solve the very specific niche problem of CI, continuous integration. So just the complicated process of integrating all the components of a software project so you can ship it. And as this software project grows larger, that process becomes exponentially more painful. And that's been true for a long time. Yeah. And we've all kind of gotten used to it as a software engineering community. And we're saying, no, we must do better. We must set a higher bar for ourselves. Integration should be less painful. It should not slow you down. It should not waste just countless hours of engineering and countless dollars. So yeah, that's what Dagger's doing. And we have a whole kind of approach to it. It's an in-depth approach, let's say, but I can tell you about it later.
Sure.
And this is my second startup. My first startup was Docker. So containers, I'm guessing the audience for this show knows what Docker is. But
I would assume so. I will say I've had some interesting conversations as of late that there's a younger generation will be
yeah,
asking about
it's true.
Docker.
It's true. I've had that experience also. Yeah. So yeah, Docker is an open source project also, and it's also a startup based on that open source project. And it introduced to the world the concept of software containers. So it kind of standardizes the process of packaging individual components of your application in a standard format that you can transfer and deploy on a lot of different servers. And we sort of tricked the whole industry into adopting that standard. And the key of the trick is to not make any money from it. And that works great. And yeah, so everyone uses it. And now there's a whole ecosystem built on top of that standard that everyone takes for granted. And Dagger is one of those technologies that is built on top of the foundational tech of containers. It would not be possible without it. And as a founder, building Docker took a long time. It was 10 years. And I had a list of things I was just so excited to build on top of Docker that we were making possible, and I couldn't wait to get to it. And building and maintaining Docker itself for everyone else to build on top of was just so all-consuming that we just never got around to it. And after 10 years, I left, took a break, started Dagger, and Dagger is like the second chapter, right? Season 2 of this arc of building cool stuff with containers. Yeah.
That's awesome. I think it's interesting to kind of walk that line of how containers have also like transformed software from where it was to where it's at now. I mean, literally, I couldn't imagine a world without them now. So, and
For better
to
or
your
worse.
point, yeah, better or worse. I mean, but it's like foundational to the modern tech stack. And so, I mean, maybe even just like zooming in on that a little bit is like, to your point on making it a standard, like how did you think about that within open source and getting people to buy into containers as a development principle that are now so widely adopted?
Well, first I would say that if Docker had not been open source, it just never would have succeeded. That's not to say every software tool or technology has to be open source, but some just really do. It just depends on what you're trying to do. If you're trying to build any sort of meaningful developer ecosystem, if you want people to build on top of it, if you want it to be a platform of some sort or infrastructure of some sort, you really have two options. Either you're already huge and you can pull people into a closed proprietary platform because you've got existing distribution, existing economies of scale. I mean, we all know the companies. If you're not one of those companies, then you got to make it open, or be extremely lucky. So anything that requires ubiquity, really, and where the ecosystem and the community is a feature of the product itself, open source is a must. So we did leverage that a lot with Docker, and with Dagger, it's the same thing. Because they have that in common. They're foundational tech that we want developers to build on top of. So yeah, it played a huge role in both cases, and we kind of have a playbook. So before launching, we actually incubated in a private little community that was basically an open source project in being, but except you just couldn't. It wasn't publicly available yet. But once you were in, it was exactly the same, and it was very clearly stated, we're going to open source this. I mean, technically, it was open source already. It had a license. It just wasn't widely distributed. And that incubation process was very useful because you can kind of build momentum. And by the time you launch, you already have a microcosm of your community. So you validated a lot. There are people out there that are interested, and because they're showing up on your well, back then it was IRC with Docker. It was a while ago. And with Dagger, it's our Discord, but same idea. So you have that feedback loop, and the repo is not empty. It's got issues, it's got pull requests, it's got like activity. And so then the day you launch, you hit the ground running, and you avoid this kind of chicken and egg scenario where it's on Hacker News, people check it out, like, oh,
Yeah.
it's like I'm the first to check it out. I'll check in a few months, and if everyone says that, then no one checks it out, and then like you're stuck, right? So that was
Yeah.
a little growth hack, let's say, but it's healthy. It kind of forces you to be in the mindset of interacting with users right away, and that feedback loop is everything. Like for me, that's the only thing that matters, just speed of iteration. Shipping something, getting feedback, shipping again, getting feedback, and the faster that goes, the happier I am. If it's too slow, I'm sad. I don't sleep well at night.
It's a good signal. I bet. I don't know if you have that in a radar of like, are your commits dwindling? That means you're probably not getting the velocity that you need.
Oh yeah, yeah. I mean, it's every day we talk about it with the team. Like, how do we move faster? You know, like what's slowing us down? I mean, every startup should do that. But you can use, if you happen to be a startup doing open source at its core and working with an open source community at its core, again, not every startup is like that, then that's your vehicle for pursuing velocity. It can be an accelerator.
I think it's interesting, kind of your point of like, how do you solve the cold start problem that many like communities really have a challenge with, and doing that as a kind of an incubation period. I don't think enough, communities start with that approach. Sometimes it's they launch it and just throw it out in the open and hope that the community comes. But I think you're right. There's something important to building in the open with a small community, getting the validation, shipping quickly, learning, and then when you're ready to go live, there's an opportunity there. I mean, maybe kind of like dovetailing that a little bit. What signals do you look for in some of those early community incubations that say, yeah, we're feeling like we got the right pull, that we should go more public or more live with our project?
Are they complaining? If they're complaining, it's a good sign.
Yeah.
You got to weed out the people who just criticize. Criticizing is not the same as complaining in this mindset, because if you're complaining, that means you're using it and you're running into issues. So that's a good problem. Like maybe you're using it wrong, or maybe we have a bug or whatever, but we have established a relationship with the user. And then you just got to lock into that, because that's gold, right? You got to ignore people who are just like, you should do this, you should do that, but they haven't used your product. Ignore. But that's the signal. If no one's complaining, it's like crickets. That's a bad sign. Yeah, that's the main thing. And I think the right size for the community is the size where you can be so obsessive and laser focused on acting on the feedback that people are blown away. Like, oh, I can't believe you already fixed it. But that's a moving line, right? If you got too many users too quickly, and they all fall down because the product's not ready, it's not polished enough, then you're not going to be able to keep up, and you're going to leave people with a bad experience. It happens, you can't avoid it, but you got to try and aim to avoid it. And so if it's happening all the time, it's happened to us. Like we had a period not so long ago where it happened to us at Dagger, because it could happen at any stage of growth. It means you're probably too front loaded on the top of the funnel, right? Like attracting people.
Sure.
But then further down in the funnel, like onboarding into the product or, scaling or whatever, then like you're not keeping up because you got too many bugs or it's too complicated or whatever. So then you gotta just double down and fix the issues. So yeah, you want just enough continuous feedback that you can see right away the patterns. Like, okay, everyone's complaining about this bug. Boom, let's fix it. And then you just kind of use that as your guide, and then you grow from there, right?
Yeah. One of the best analogies I've ever heard about this is, think of it as a tire. And if your tire has a leaky, or it's leaky, you don't want to spin the tire more and add more users. You want to keep finding this balance of like making sure there's air in the tire, spinning the tire, and keeping it going. And it's a really good analogy to think about, because you're right. I mean, as you have to shift, if you're putting too many people and you're just leaking through the tire, you're not going to go anywhere. But if you fill the tire, it'll ultimately pop if you don't actually keep adding, velocity to it. And, so anyways,
what's interesting, that I mean, a lot of times there are two worlds that are adjacent, but a lot of times not connected, which is the world of open source and the world of startups. And both of these worlds have known techniques, known playbooks that are just known to work, common sense. And then there's ongoing, both are evolving, there's innovation, there's debate, but there's a solid common body of knowledge that's been developed through craft. And both these worlds could really benefit from learning from the other. And so if you combine them, like what we just said, that's applying a very standard startup tactic to a management of an open source community, right? Which is start from the bottom of the funnel, start from retention, because otherwise you're just, like you said, you're just wasting. You're putting air into a leaky tire, putting water into a leaky bathtub, whatever.
Yeah.
And that's just like Y Combinator will tell you that all day, regardless of if your thing is open source or not. Turns out it applies great to open source. And the opposite is also true in other areas. Like nobody does community better than open source maintainers for a strong project, right? Engineering quality in general is higher. The processes are well known. You can distribute the teams. There's lots of benefits in that direction also.
Yeah, I love that kind of learning from each other comment, because one of the things I see both on the community side of open source, trying to figure out how do we make it more sustainable, how do we drive engagement. There's a lot of the same tactics that come across the lens of there's pricing and packaging to make sure that the community has the right funding. There's product placement. There's channel fit. Like all of these things that I think are really unique. Definitely makes sense in the communities broadly. Maybe shifting back to kind of the origins of Dagger and kind of how you thought about your 10-year journey of containers and getting into CI. Like what was it that made you say, hey, we're not at a point of ubiquity in containers that I need to shift into CI as like the next big problem to solve? And what was it that gave you the insight to focus on that piece of the pipeline versus other, parts of development?
Yeah. Well, it's interesting because the ideal startup opportunity, it combines two things. It combines a very ambitious, almost ridiculous horizon for how big it can get and how valuable it can get. And I mean valuable as in it creates value for people. Money just flows from that. But the point is, this could really change things, have a big impact. It's the kind of thing that I could see myself working on for 10 years or more. And at the same time, you need to combine that with a very narrow, very pragmatic solution to a specific problem that people have today. That is the opposite of a big, lofty, sensational ambition, right? Because customers don't care how ambitious you are. They just want their problem to be solved, right? And so those are two very different things. But if you could somehow connect them into a cohesive plan and vision, then it gets really interesting, because you can aim big and execute every day in a concrete way and not get lost, right? So Dagger is our version of this. The starting point, like I said earlier, is, wow, we have this container tech now. It took 10 years to discover it, develop it, get it widely adopted, polish it, build this whole ecosystem, yada, yada, yada. So like there's a checkpoint. Now containers exist, they're taken for granted and they're solid, and we've kind of explored the ramifications. But really all we've done is taken the old way to run applications and develop them and just kind of shift them onto containers, right? Because you get benefits right away, right? But that's now where we can finally enter a second phase, which is to start container native. Like the day one containers exist, and not just the janky early version, but like the really solid primitive. So if that's your starting point, how would you design the whole stack? Like the programming model, the operating system, just how you think about your software, how you think about deploying it, the whole thing, right? Because really, people haven't really done that, I think. And the reason for that is that containers, the reason containers were successful is specifically because in this first phase, they did not force people to change all that.
Right.
It was a drop-in compatible tool with the existing platforms, the existing software, specifically Linux, right? I mean, basically, all of the internet is built on Linux now. All of the cloud, and by extension, all those crazy AI stuff. It's all
Right.
Linux all the way at the bottom, right? And so Linux is the platform. Linux is what, like decades old, and it's not even as old as the APIs that it's built on, right? The POSIX APIs, the original Unix. So we're basically, if you're writing an application today in Node.js, in Python, and whatever, like the coolest, hottest new thing, that platform is still there. You still have to think about it. You have to think about a file, a process, an environment variable. These are things that were invented 50 plus years ago.
Yeah.
And we're very limited in our ability to change them because it's like redoing the foundation of a 100-story skyscraper. So what do? We add an extra floor, right? We're just adding layers and layers all over the place. And that's the internet today. That's the cloud. And if you dig in the lower layers, it's kind of ridiculous how inefficient and janky and just patched together it is. And everyone dreams of just rebuilding the platform for the future. But like, how do you actually do that, right? So, our approach.
Yeah, I was gonna say, I think that's a really poignant comment that, you're kind of building on the scaffolding of an existing architecture, so you can't fundamentally
Yeah.
change everything. You have to
Yeah.
build within the constraints of the environment. So
Yeah.
that's really good. Yeah, maybe would love to hear your approach to that.
Well, our approach is, because we're not a giant company that can force every developer to change how they write their applications. And by the way, even the largest companies are really struggling to do that because compatibility is very appealing. It's very unappealing to have to throw away all your code, right? It's very hard. So
Very
compatibility almost always wins. It's very, very rare. If you're ambitious, if your ambition is to basically create a new operating system for the next 50 years of software, right? It's all distributed by default. It's just cloud native, AI native, whatever. Like, what's the operating system for that? I know it's not Linux, and I know it's not whatever we're taping together, right? So what is it? Well, if you ask any hyperscaler company, they'll have an answer for you. Like, oh, of course, it's Super Cloud 2000 platform combined with our brand new thing, right? All you have to do is take your web application, take your cloud backend, take your agent, take your cache, and take the whole thing, throw it all away, and start fresh with our Super Platform 2000, new and improved. And like it never actually happens that you can just fork everything over, port everything 100% on this new platform. It just doesn't happen. So you have a patchwork. You just keep patching. Maybe you'll use the new global platform 2000 for one piece, and then you'll tape it to the rest, and then you'll keep building. That's what actually happens, right? So that's the fundamental problem. And so our approach is to not try and do that, not try to convince everyone to shift over, which, by the way, even if we tried, we would fail. But it's to focus on what's in front of everyone, which is the actual taping together. What if you embrace the fact that it's all tapes together, and instead of trying to make the taping together go away, you created a whole system that is built around this concept that you're always connecting things together and integrating, and you focused on the platform for that. So that leads us to CI, because CI, the I is for integration. Like I was saying in my little intro in the beginning, it's all about gluing things together, which everyone has to do. Every software team has to do it, except the very, very lucky small teams that are so small that there's nothing to glue together because 100% of the whole thing fits in one monolithic platform somehow by some miracle.
But that's
Not going to
rare.
last. Not going to last. Yeah, and if
Yeah.
it's rare and also very ephemeral.
Yeah.
As soon as you're successful, you start taping stuff together. You can actually measure. I think it's a proxy measure of how successful a software product is by how many horrible taped together scripts there are under the hood. Right, because like there's no time for that. We can refactor the whole thing. Yeah, there's no time later because we gotta like scale the thing and
yes.
But it does.
To your point, velocity matters. So you're solving the pain point. And you're just moving. Yeah.
So we basically like the approach of Dagger. It's kind of meta. But like this is not our pitch to customers because this is a long pitch. Our pitch is, your CI is, if your CI is causing pain, we can solve that pain for you. Your CI can be 10. It can be 10 times faster. It can be 10 times cheaper. It can be actually written, like managed in code in a language that doesn't drive you crazy. And you can run the same thing locally and in the CI server. Yes, all these things should be possible. And it should be completely open and portable across infrastructure. It should not be tied to infrastructure. That's the pitch. That's it. But what I'm talking to you about here is like, why the hell are we doing this and not something else? It's because solving CI is a gateway to solving an expansion of that problem. That CI is the visible front of, which is the gluing together, what holds your entire software stack together in the age of cloud, basically. And embracing the fact that every software product will do that slightly differently. It's a unique snowflake every time. So the model of find the perfect all-in-one platform and build your app on it is completely wrong. It's the other way around. Every software team eventually builds their own platform around the product, right? And you can think of that platform like the factory that ships the product.
I love that. It may be kind of like dovetailing that conversation a little bit is, what design principles or like fundamentals did you take when rethinking the future of CI in this, cloud native world, but also kind of where we're going right now with AI native?
Yeah. First principles, simplicity, modularity, and in our case, starting with the fact that it's a true software platform. Think of it as an operating system. How would you design it? If you think of, like, we don't think of CI. CI is not a product category. It's a workload category. It's a type of application that you develop. That's what it ends up being anyway. Like you can buy your CI to say we're a CI product. You can buy this product and then you can configure it with YAML or whatever. But in reality, that YAML plus the bash script next to it, plus the special custom tool, plus the glue because you have another CI, like you're actually programming in the worst possible platform ever made, because it wasn't designed as a platform to run your application. It was designed as a product to configure. But we're saying, no, your CI is an application. You're designing and engineering two things. You're designing and engineering your product, your software product, whatever it is. And at the same time, you're designing and engineering the factory that will assemble and ship that product. Those two things are co-designed, co-developed. You cannot decouple them. You can't buy a factory at the factory store. That's not how it works, right? It's the same thing in actual manufacturing. Like if you visit the Tesla factory, for example, or whatever, Boeing, like those two factories are nothing alike. Because they're specific to whatever is being built. So we want to enable that. But you should be able to do that out of some sort of standard modular system, some sort of platform for the factory itself, right? Like what is the platform that you can build the factory itself on? If the factory is software, what's the platform for that software? And that's our entry point into this broader problem, because CI workflows are really interesting because they're very constrained. They're a very narrow type of application, right? They're structured like a DAG, like a graph. It's basically, it's like an assembly line in a factory. You've got
Yeah.
stations, and you got stuff flowing through to the next station, data flowing through, and that's a really, for software engineers, as you know, that this is a very cool shape of a problem, because if you can shape your software as a graph of data flowing in one direction through nodes, there's a lot of very cool stuff you can do. You can build a platform that is magically faster, more scalable, more repeatable, more secure, as long as you only run programs shaped like these DAGs. And so that's what we're building, an operating system for software that's shaped like DAGs. That's not a very exciting commercial pitch. Like, no one's going to buy that. But it turns out there's a community of system engineers that are very excited about that, because they have the same spidey sense that this is important.
Sure.
And that now that containers exist in the world, you can actually build it in a very elegant way on top of this primitive that is containers. And so if you look at all of this plan together, CI is like our niche. It's our niche application market that we're entering as a platform. And what's interesting is our customers don't even think of it as applications, but we're educating them to say, think of your CI as an application that you're going to develop, and then you're going to deploy it on this platform called Dagger, and it's going to be awesome. And then what happens is, once they do that, they start looking at other things around their CI that their CI is attached to. And they think, oh, that also looks like a DAG. Maybe I can just keep Daggerizing. We call it Daggerizing. And it turns out a lot of your application delivery pipeline works better if it runs on Dagger.
I love that. Maybe for someone that's kind of like new coming into Dagger, like, where do you get them started? Like, what's the first thing that you do to say, hey, this is how you onboard, how you develop an application for CI? Like, what does that look like?
So, like, I think every single software project ever, we are unhappy with our current onboarding. But basically, the most important principle for Dagger is to adapt to the user. So that's why integration is such an interesting word, because by definition, there needs to be something to integrate. So it's not the same as build. Bazel is a build tool, Gradle is a build tool, Go build, et cetera, et cetera. There are plenty of build tools. They don't need to integrate with anything, right? They're part of a native platform. You write Go code, you run the build tool, it builds a binary. Okay. Integration is what you do before and after that, and all around it. It's the context for the build. Like, where did the source come from for this build? What version of the build tool are you running? What system dependencies are installed? Once you're built, like, are there multiple architectures to build for? Okay. Once you've built, where does that artifact go? Does it get bundled with another artifact? Does it get tested? If it gets tested, what's the environment for testing? Does that environment have dependencies? Oh, do these need to be built? Oh, what's the environment for that build? What are the inputs for that build? How do you connect them? So that's, let's say, the context that for executing all the different tool chains that are involved in shipping. So build tools, test tools, linting tools, deployment tools, there's a gazillion of them. And you need to orchestrate the context in which they get executed and move artifacts around. And that's what Dagger does. So you can think of it as a context engine. So back to your question, how do you get started? There's a CLI. You start usually in your Git repository with the Dagger CLI, and then you go to a part of your repository that you want to Daggerize. Okay. It could be the whole repo, but for larger teams that have a huge amount of repo, it could be one piece, one area of the repo. Dagger is 100% monorepo friendly. And then you go there, CD, whatever, and then you go Dagger in it. and it drops a little JSON file, dagger.json. It's like 5 lines that says this directory is now a Dagger module. So that's your little that becomes a context for executing things, orchestrating all the things I talked about with Dagger. And the word context is very important because unlike other software platforms that execute things in a vacuum, like if you do Docker run, you're running a container. That's it. If you deploy to Kubernetes or whatever, it's running. It's there. You connect to it. Dagger is different because it always runs in the context of a specific place in a specific Git repository, and it's like a little parasite program. It's a guest software project that's attached to your host software project, and every time you run it, it has access to your main project's files, basically, because it's the purpose of that little program, is to be the factory. So it needs to read the source files, to plug them into the build tool. It needs to spit files back out. So, and then you just write these little programs, these little functions in the language of your choice. You got a bunch of SDKs, Python, Go, TypeScript, PHP, Java, Rust. And then you just write these little functions that describe exactly the context you need to build, the context you need to lint. And then you just call these functions from the Dagger CLI. The nice thing is that's the whole point of Dagger. Once you've defined these functions, they run the same everywhere, and they run everywhere. So you check those files in, your colleague checks them out. They do Dagger call build or Dagger whatever. This exact same thing will happen. Same version of the build tool, same inputs, same.
So you get a lot of consistency across the entire
huge amounts of
pipeline
consistency, and awesome. you get consistency across the tool chains in your project. So the front end team can Daggerize their front end, which uses the npm tool chain. The back end team can Daggerize their part of the repo that has a Go tool chain. And so they each have now the standard, these standard building blocks to encode checks to run, artifacts to produce, and then they can integrate with each other through a standard API, but each writing in their own language. So we've solved, to do this, by the way, we had to solve ridiculous amounts of software engineering design problems. Like we have cross-language APIs, kind of like gRPC or REST API, except it's object oriented. So you can produce an artifact like a container, a directory, a binary file, or like a composite of those, or a secret, mix them together. And then you can pass that as a reference to another function that's calling you. And your function is written in Python, their function is written in Go, whatever. And that object will just stream right through, and you can keep using it. It just kind of flows from function to function. Sorry, I don't know if this is maybe pretty abstract, but the bottom line is you have a very simple, elegant development experience that requires building very little code once, and then your whole software team, your whole team has this playground to just combine everyone's builds, everyone's test processes, and they don't need to learn each other's tool chains.
Right.
And they don't need
Which is, really important just for like speed, but also just given the world of development, you don't always have the knowledge of another team's code base and kind of where they're at in their cycle. So that makes a ton of sense.
Usually what happens is, we work with teams that have silos, right? It could be just 2 silos. Sometimes it's 1,000 silos. It only gets worse as you grow, but within each silo, things are generally good. Each team has their native tool chains. They're happy. They're running. As soon as you have to cross the boundary of your silo to integrate with another one, to ship, or just to test your version branch against some other version of this other service or whatever, that's when basically all hell breaks loose. And you have, I've seen crazy things, because of course we talk to many teams and look at their CI, the npm scripts, wrapping shell scripts, running custom generators that spit out a YAML for another tool that, whatever. It's crazy, because you're just, you got to run, and because there's no hub to interconnect all these things, you just gotta you write one-off scripts, and all that stuff meets all that complexity. It kind of rolls downhill to your CI, so it all ends up in this giant pile of YAML or Groovy if you're using Jenkins, and shell scripts and all that, and no one understands it. Usually there's one person.
Probably adds a ton of security, a lot of risk, a lot of maintenance that is so flaky, brittle,
well, it becomes
whatever.
it becomes a huge bottleneck, because if you need to change it, then there's only maybe one person or one team that can change it, knows how to change it. But every developer at some point will depend on it. So you want to make a change to your tool chain, like, oh, we're using this version of the build tool now. You got to go ask someone to upgrade it in CI. Otherwise, you got drift between development within your silo and what's going on at integration, right? So the process, the experience of using Dagger that I described, just a little CLI, just a little file, a few functions, 10 lines of Python here, 20 lines of Go there, and then boom, you start interconnecting. That lays the groundwork. That's like the Lego bricks that allow you to just approach that problem. It's just in a completely different way.
Yeah, I'm going to spotlight a question because I think it's really relevant to this, but kind of the cross-language object passing, and how is that coupled within Dagger, or is it, a separate use case that you see often? And just kind of curious how you've solved that problem for your customers today.
I totally forgot we were live. Hey, everyone. Yeah, so I mean, the point of Dagger, yes, it's coupled to Dagger, but Dagger is not coupled to anything. So the point is, you can run Dagger, you can embed Dagger in a million ways, and just wrap Dagger right inside whatever you're building. Think of it as an engine, like a coprocessor, right?
Sure.
You give it whatever it is that you're doing, whether it's a custom application delivery platform, or people develop AI agent workflows on it, that's a whole other thing. But also just anything that you can shape as a DAG, where it's valuable to have full repeatability, cross-language integration, caching. Everything's cached by default, all these cool properties. You just embed Dagger in your project. That's it. And that, you can call it from the outside. We've got, you can generate client bindings in all those languages, and you just link to that. And there's a bunch of ways to do it. But think of Dagger as a context engine that it's really good at running software of a certain shape. And CI, just the general, the kinds of things you run as part of CI just happen to be of that shape, but a lot of other things are also.
Yeah. I want to circle back on one thing that I think is interesting with more AI or agentic driven coding. How do you envision this accelerating that? Because I actually think, to that point of context engine and orchestration, I don't know how you can have a world with AI driven agentic coding without something like this to provide the context. You're almost 100% solving the MCP layer of coding by putting that into the context of your module, your repos, et cetera. And I'm curious, how you see that.
So, I mean, this wave of agent engineering, and now I'm hearing context engineering, is a windfall for us, because that's basically what we've been building for years, and we've been building it for humans. But the premise is, hey, humans can develop pretty fast, and it doesn't make sense that an automated system, which is your integration, is slowing down a human. Normally the automated system should be faster, but right now you're slowing down the humans. Now take that and now bring agents that code 1,000 times faster. How much do you think you're slowing them down? A ridiculous amount. And it's kind of literally in the last few weeks, it's become this very trendy topic, which is very exciting to me, because I know what the logical conclusion will be. We're entering a phase where people are going to throw all sorts of custom tools and crazy AI native things at it, and then they're going to realize, oh no, this is actually a very generalized problem. I can't just patch some AI context thing. I have to rethink the whole stack that provides the context end to end, whether it's to the agent, to the human, to the CI server, whatever. And that's what we're doing. So for example, at some point, of course, we had a spike. Like, okay, how do we connect with this agent thing? And we did a few things. We have a few more underway, but none of them required some big change.
Sure.
We're adding. It's like adding a new Lego brick. That's basically, it's like 100% like Lego. And I know it's like a used metaphor, but really, really it is. An enormous amount of the engineering and design effort in actual Lego goes in the individual brick. And you have to sort of extrapolate the impact on the whole system and what people will build. But then you're obsessing over the one brick.
Sure.
And then I would love to be a fly on the wall in these design meetings at Lego. They're like, we need a 5 by 1. No, it's a blasphemy. It violates principle 32. Like, that's basically us every day on our Discord.
Oh, I love it.
And it's a lot of fun. But like for agents, for example, we added MCP integration. So once you've Daggerized, you've defined these functions, and those functions return objects that can have other functions. So you're just chaining things, so it's like your own custom contextual API. Here's exactly how to test my project and to build my project. And you can build insane, like it scales. Like, for example, we use Dagger to build and test Dagger. And as you can imagine, that one's pretty gnarly because it involves a lot of Dagger in Dagger and just looks ridiculous matrices, but it always works every time. I can get, like, right now I can point at any PR in our repo, and I can get you in one command an interactive playground of that build of Dagger, the engine, the CLI, every SDK, all wired together. And that's how I actually test PRs.
I love it. Maybe we should segue into a little bit of a demo
over MCP.
Yeah.
Like you run an agent, you give it Dagger as an MCP, and you run it in the context of your project. It automatically has access to not just general tools, but your project's tools.
Which is critical to making it work.
Yeah, it is. The other thing that we've been working on is now in the Dagger API itself. So that's an agent calling Dagger, but Dagger can also call an agent, because it turns out,
interesting.
Agents are really, it's a mix of, you can really break them down into agentic loops, right? And like a deterministic workflow. And both of these things you can express as functions.
Right.
So you can express an agentic loop as a function that you give callbacks to the other functions that I can call. And then that function prompts an LLM and says, here are the callbacks. And of course, the LLM sees tools. Here's your prompt. And then, you decide what you want to call, blah, blah, blah. So the agent's like looping. That plugs perfectly well in Dagger. So in any Dagger function that you write, whether it's your build, your test, whatever, you can add a few lines and say, oh, give me an LLM, give it these functions, these Dagger functions in my Dagger functions, or the team next door's Dagger functions, whatever. And just run. And it's you're just handing control. Your function hands control to the LLM in this very controlled sandbox just for this one purpose. But your function itself is part of an overall deterministic, reproducible workflow. So you're in control of what's deterministic and what's not in a very fine-grained way. And honestly, I think that's the future of agents. I think right now we're in the craze of monolithic generalists, agents, whether it's the hosted cloud version, the CLI version, like the CLI that can do it all. But at the end of the day, the only two things that matter are the LLM itself, bigger, smarter, faster, whatever, and the context. That only two things that matter. Everything in the middle is like going to be a commodity. Oh, great. You wrote a way to apply a diff on a file. Congratulations. Right. What really matters is what file should you develop? How the hell do you build it? That's context. And then is your LLM going to actually produce the diff correctly, or is it going to throw some emojis in there? Those are the only things that actually matter. So
But the only way to do the right thing is to have the context, which is
yeah,
like the most critical thing.
yeah. So what we're seeing now is like we're seeing system engineers building with Dagger. They're just inserting little bits of agentic functions for the parts of their workflows that they're comfortable handing over to agents, knowing that they have full control because they know the whole design principle of Dagger is repeatability and sandboxing. And we ourselves, there's one guy in the Dagger team called Alex, and he decided to build his own Claude code on top of that. And he stopped using all the other agents, and he's using Dagger to develop Dagger, which cool. I think is super cool. I mean, I know it's like there's 1,000 agents thing, so we're not going to pivot and be like an agent company, but I really think we're laying the groundwork for the convergence of agentic workflows and regular software delivery workflows. Those things are going to merge, and it's going to be really fun, as long as you have a platform that can actually sustain it.
Yeah. No, I love seeing that and hearing that. I know we got a couple minutes on. Do you still want to try to do a little bit of a demo on how Dagger builds?
Sure. Yeah.
Dagger?
So I didn't. Before recording, Kevin very kindly asked, "Do you want to do a demo?" And I had not planned to do a demo. So the only kind of demo I can give is a very rough, unscripted one. But yeah, I guess let's do it. Let's do it. Just to give a general sense.
I think folks will love it. So,
should I share my screen? Or
yeah, go ahead.
Okay.
As soon as you're ready, I'll bring it on.
Okay. I don't know if did I even answer the question from before?
Yeah, you did it. Yeah, that was good.
All over the place.
All right, I will bring it up and then I will make it big so that folks can see that.
So, so this is I use shout out to Zed, my new editor of choice. Love it.
Very cool. Fast and speedy, I think.
Got me to switch from Vim.
Okay.
Yeah. Okay, so this is just a random example software project called Greetings API. I'm not even super familiar with it. I just checked it out for this demo. But the idea is to show, how would you Daggerize a small project? Like it's kind of a playground. And I can show you how we use Dagger for Dagger, which is not a small project. More realistic. I don't show it first because it's a real project, so it has warts, always will. And so, it doesn't make Dagger shine as much, but anyone who's actually managed the build and the CI of a real big project will be like, "Ooh, that's nice." And then wow. Okay, so I'm in my repo and notice there's a Dagger.json.
Yep.
And it's a little bigger, but basically it says this is the name of the module. This is the version of Dagger it needs. This is the SDK it needs to develop its functions, right? And here are the dependencies. So this is the magic where a Dagger module can automatically call functions from another Dagger module. And this is basically a full-blown sandboxed, repeatable. It's a universal package manager for cross-language sandboxed functions. So here you can see, it's importing different parts of this repo that are like model as different modules. So the backend team, the front end team, they each have their little area, right? So if I'm in a project that is Daggerized,
is it running on a separate screen? It's not showing. The changes are not happening right now.
The changes are not happening.
Well, so on what I'm seeing right,
I'm sharing the wrong screen. That's why.
What you're saying is not mapping to the.
It is not.
Function.
It is not. Yeah. Sorry about that.
All good.
Good. It means you're paying attention.
Yeah. I'm like watching. I'm like excited for what you're saying. There we go. Now I see some stuff happening.
Okay. Yeah. I guess just checking there were no API keys in there. Yeah. Okay. Good. Okay. So Greetings API, just a little random software project. You can see there's a Dagger.json.
Yep.
And that's what I was saying before. Name, engine version, SDK, and then a bunch of dependencies. And you can see some of those dependencies are remote. Like this is a module to manage GitHub issues. This is a module to manage GitHub releases. Actually, these things integrate with the GitHub API itself, but via like a sandboxed Dagger API. This is when to run a proxy, like to proxy your services. I don't know what that is. And you can see there's a local one here, like, oh, there's my back end is also Daggerized. My front end is also Daggerized. So each team, can you imagine, has its own like little area. So here, so the result of that is I have a bunch of functions, and I can list them by calling Dagger functions. I'm using this experimental feature that we haven't released yet, where you can just this is on my laptop, but because everything's sandboxed and containerized, you can do the actual computing on a remote Dagger engine, and then everything gets kind of streamed back and forth.
That's pretty cool.
But it does mean there's a little bit more upload time because
Sure.
my internet is like, anyway. So here you can see it's loading this module, and you can see it. Oh, you can, if I want to trace what's going on, everything's traced. So this is a full trace, is like tracing every single operation of building these functions. It's loading it, and then you can see, okay, these are the functions that are available. I can build. So if I Dagger call build, now it's going to like orchestrate exactly the build in this repeatable context. So I can see, okay, what's going on.
I have some really cool thoughts on like how you could take this context, feed it back in, and essentially like self or continuously learn your context within your modules too, because you can see where things break and where they're
Totally.
slow. Or yeah, this is super cool.
Yeah, so it's always containers at the bottom. Again, like this whole thing exists only because containers exist. And for those who know BuildKit, like it's the underlying tech for Docker build. Dagger is basically built on top of BuildKit.
Okay.
It's an API cool. And like a whole platform on top of this fundamental DAG engine that is BuildKit. Okay, so I called a build and it returned a snapshot of a directory. It's just there in cache. And now I can do things with that directory. So how am I going to do this? Okay, we have a little interactive. Okay, the part I'm not actually familiar with this module, so I'm discovering it. I'm like, oh, what does this do?
There you go.
Not ideal for a fancy demo.
True live demo.
So if you run Dagger without arguments, it starts this interactive shell basically that deceptively looks like a bash syntax, but actually it under the hood it calls the Dagger API. So I can list available functions. These are the same functions I saw before, like build, etc. The difference is I can easily chain things. Like, okay, I'm calling this build from before. Normally it should be very fast because it's cached. So now I have it, and now I can go, okay, what can I do with that directory? Directory is a standard artifact type in Dagger, so you can do a lot of things with it. One thing you can do is say, okay, just give me a terminal so I can just like mess around with that directory, just an ephemeral one. Boom. Okay, so now I'm figuring out, okay, what's in there? You know, okay, looks like it builds the API, the website. Cool. Can I what else can I do in there? Oh, there's some agentic stuff in there. Run the CI checks. So if I call check, it's just gonna like make sure everything builds, I guess. Okay, so while that's all happening, the point is I don't really know. This is actually realistic. I'm in someone else's silo. I'm like, I don't know how this works, but I know how to build. You know,
you know how to build. You know how to check. You know how to like get. Yeah, that's huge.
So these traces that you're seeing, this is actually all standard open telemetry.
Okay.
And optionally, we can send it up to this telemetry service called Dagger Cloud, where I'm looking at the trace in real time of what's happening. And I can see, okay, so this is when I called build, and I can see what happened in build. Well, it opened this directory, excluding these things, and then it passed it to this greetings function. It started a container and mounted this into this. Then it executed. It pulled this container from this distro. It copied this file, and so you can kind of trace back everything that happened.
Yeah.
Extrapolate to a real big project like Dagger. This is our org, where we basically hook up all of our Dagger engines to send telemetry. And what's cool is everything I'm running locally also runs in CI. You can run in CI. You just configure your CI server to do Dagger call this, Dagger call that, and that becomes your CI. And that also sends traces. So here on the right, you can see all the traces coming from local installations of Dagger in our team. So that's me right now.
Okay.
That was me earlier. That's Alex. That, you see the team like doing their thing, and it's actually fun to go see like what the hell they're doing. And then, so here, yeah. So he's like, oh, some things. Oh, I know what he's doing. He's debugging an issue that we had yesterday. So he's just like trying to figure out why this is failing on his laptop. Meanwhile, in CI, every time you push a PR, that triggers a bunch of calls because we have a big CI machine factory, right?
Mm-hmm.
And like you can see all the pull requests here, and you can see this PR right now. It's running right now, so you can see. Actually, I think that's the same. We have this issue with this check, so he's probably checking right now, and you can see it happening in real time in the CI server, right?
That's
it's the
so
same
cool.
logic. It's the same workflow.
I mean, this is like redefining what real-time collaboration looks like while you're building this too.
Yeah.
Yeah.
So
This
here you can
is.
see like a more realistic trace. Like this is a real gnarly build. The
Yep.
typical Dagger user like has some pretty like you need this. So you need to experience the pain of the complexity, or it's either large teams
Mm-hmm.
that have this hair on fire problem, or small teams that have an engineer that has that had that experience before in a previous job and is saying, never again. I'm doing this earlier at this time.
Yeah. I imagine like day one, you'd almost want to implement this just so that you have a standard culture of
Yeah.
having context across your build. Yeah,
That's
this
what
is huge.
I mean, I agree. Honestly, the trade off of all this is we started out, it's a bottom up design. To take the analogy of Lego, we started out with bucket of bricks for expert builders who intuitively get the need for Lego.
Mm-hmm.
And then gradually we're polishing and making it easier and easier to get started. We're actually right now going through like a 2-month sprint where we're going to make it, I think, at least twice as easy for teams to get started with Dagger. And so then that lowers the bar for entry. So it justifies, over time, it becomes justifiable to start using Dagger sooner and sooner and sooner.
Mm-hmm. I mean, I imagine too, to that point though, like we talked a little bit about startups and open source at the very beginning, but that the idea that if you're starting with a full kind of a newer solution of how you build companies, you almost want this to be part of the culture right out of the gate. So if you had like a launch idea of like, okay, if you're going to redefine your entire process, add Dagger as like the first out of the box thing you employ, and then for your teams as they grow and scale, it's just adding a net new context or a configuration within the platform. So like it actually makes sense to almost use that as a corollary to the open source of just having like a startup version that they're getting started with this at the very,
Actually, I should. I think by showing the in between, I should not have shown that Greetings API project because it's like I should have shown either doing it from scratch or like full blown Dagger. But just to show you real quick, this is how you go from scratch. Dagger init, choose an SDK. Like let's pretend we're in like my project, right? Okay, that's a lame project, but let's say it's my project. I want to Daggerize it. Dagger init, pick my SDK. SDK equals go. And then it's going to do its thing, like set up a little bit of a scaffold, and this cloud thing. Okay, it scales great, but we got to do something with it, like connecting latency.
Yeah.
The nice thing though is you can point your CI runner at this, and it's going to scale out your functions really nicely. Because guess what? Repeatable functions with full sandboxing and immutable inputs, immutable outputs scale really well. You can spread them out in a cluster. Yeah. No problem. Okay, so now I have, here's about the license. So now I have my little dagger.json. And here we have a little .dagger directory. So we just tuck it in. That's the parasite, right? We just tuck in this little Go project attached to your host project. And you can figure out how it gets attached, yada yada. So this is just the default. But then if I go here, this is where is it? Oh, that's the wrong. That's my actual project, my host project, which is empty. And this is like this is a Dagger module.
Okay.
basically, let's say I want to define my super build. An awesome build. You know, I'm in the Go SDK, so this is I should feel at ease as a Go developer, right? And I'm going to build perfect container, and you can see this kind of this chaining style. Pull this image, execute this. You know, just install a bunch of packages, whatever. Let's say I want to, and I just return. Say I create a container, do stuff to it, I return it, and I have this. I'm returning an actual container type. If I call Dagger functions on that, this close to disabling my cloud thing.
I mean, it's still snappy, but yeah.
Yeah. There is a price for repeatability. I will say that. You can't beat a native toolchain, but we will get this down to sub 1 second. Okay, so
you said it's still in beta, right? So it's okay.
The cloud thing, yeah. So now I have this function super build that I just wrote, and I can call super build, and I can say, okay, call it. You can see what it's going to do. You can see it in the trace here. You can see it in the TLI and the TUI. Sorry. You can see it's done, but I asked it to stick around so I can keep browsing here. But you can see, okay, it called in my demo module the super build function. It called container. Let me just look side by side with the code. Container from this with exec this, and you can see container with exec this, and here I can see what the output, what happened, and then I can see the same thing in the web version, right? Okay, so I got a container, cool, but what do I do with it? Well, I can publish it to a registry, just chain a publish call. I can, download it, whatever. Keep executing things from the CLI, or I can just say, give me a terminal just to see what's going on in there, and then the actual build was cached, and now I'm in my little container. I can see rsync is installed, and if you see in the trace, you can see the terminal in there, and in the terminal you can actually see the session. Hello. So you're really monitoring everything. Oop, that's a bug. Hello. And then you're like, okay, well, I want to keep iterating. So we have this change line here, rerun, and that's it. You're developing these functions.
Yeah, that's awesome. That's super easy too, to just be like, add these new functions and then have them easily, usable within the CL. Like, yeah, this is great.
Let's say I want to pass a secret or a source or something. You can pass directories as arguments. So here I can say, you know what? Let me just add a directory. At foo, I'm going to add, or at src, I'm going to add that variable. So this function requires a directory now, and I'm going to mount it here, and then I'm going to return it. So now if I call super build, the same command as before, it's going to say, oh God, okay. I'm disabling it. Come on.
Still fast though. This is good.
Yeah, we'll be faster. Oh, you need an argument called source now, right? Because that's the thing. That's the argument. Let's see. Okay, wait, but okay, so let me pass source. What do I pass in there? Well, you can pass a local directory, like, I'm going to do this different. I'm going to do this with a shell. It loads once, it'll be faster. This little interactive shell. Let me pay that tax once. Come on. All right, super build. Oh no, you need to pass a source. Super build dot pipe terminal. Okay, now you can see. Oh, and it's such src we said. Okay, there it is. That's the source directory mounted, right? Actually, I changed my mind. Don't pass dot. Pass the source of Dagger at main, but only the the docs. So now it's fetching that. It's got native Git operations, And now I've got another container, and this time in src, these are the docs for Dagger and the docs, and the branch, yeah. So You just got this, any artifact really. We've got directories, containers, secrets, same idea. You can just plug these in. The nice thing about that is you can parameterize everything. You can even pass as an argument a service endpoint to like your test database. And then if you run it locally, you're going to plug into your local database to run tests. If you're running it in CI, you're going to plug it into some other database with different credentials, but the logic can remain the same. That's typically the kind of thing that you can't do with a shell script. You end up having one stack of scripts for local dev, another stack of scripts for CI, and then you get drift, and then the problems start.
And then it
Anyway,
continues.
as promised, my demo has been rambling, and
this is great. I think it's always good to see a live demo. Also, and I think the expression from like getting started from day one, also to like a large project, is helpful for folks to understand. How you can, streamline it to the fit of what you're trying to build. So this is really good. Yeah, maybe kind of like dovetailing that a little bit. And I know we're getting close, but
dovetail.
How can people engage with the project, the community, get started with work, if they want to reach out?
Okay, so the number one thing, if you're into this general problem area, it is a niche problem. It's one thing we've come to terms with is the Dagger community is not a huge community that can welcome all developers. I mean, everyone's welcome, obviously, but most developers don't care about this stuff. They just want to write their app and they want someone else to make sure it ships, which is totally fair. In that way, we were different than Docker, which, ended up being a tool that many developers, except maybe for the new generation now, just would use every day. And so that means different size, right? So it is a niche community, but it's a community that is on average more experienced. They've seen things. They have more range, because you're like running the system that runs the apps. And so we're basically like our community, our Discord in particular, our GitHub repo, it's like a support group for system engineers that have experienced the pain of being responsible for integration in every sense, the build, the tests, the deployment, like the whole thing. And it just, if you're into that kind of problem, if it's that your thing, then you should 100% join our Discord, because it's just a lot of fun. And it's really interesting to see the commonalities across industries, across company sizes. Literally everyone has this problem. And you have game studios, tiny startups, banks, people will say, I can't tell you where I work, but they all have like the same integration problems. And we're basically all together designing the solution. So we're in there just like review, brainstorming design ideas, like basically like asking the master builders in real time, hey, what do you think of this brick shape? Would that be cool? Oh, but yeah, could you make it like this? Because I have a problem that I have a thing I'm building that would be perfect, and it's just that all day long.
That's great.
So you should
like
join
the best way to design
exactly.
and build in the public, right? Is to like get that feedback. Yeah, that's great.
Yep,
love it. Well, I want to thank everyone for joining us today. And Solomon, thank you so much for the demo and giving us an overview of containers and the DAG workflow for Dagger today. This is awesome. Would love for folks to reach out, and if there's a way to contribute, plug in. Any call to actions for the folks to jump in today? Any ways that you want them to engage with Dagger going forward?
Yeah.
Awesome.
Discord. Join the website. Do we have time for one more command?
Yes, one more command. Let's do it.
Okay, I want to show you how I review PRs on Dagger. So, for example, I'm working on this PR right now to add a concept of checks. So you can call Dagger checks, and it will find those functions in your module that fit the profile that will return green or red. Bill tests, lints, like that way you don't have to add in the README. Make sure to Dagger call this and Dagger call that. You just when you want, before you open your PR, you call Dagger checks, and it's just going to go and run everything. So I'm developing that. So how do I test this Dagger feature with Dagger? Well, what I'll do is I just point at a remote module instead of a local checkout. Like I don't need anything locally at all.
Okay.
Except for Dagger. And I'm going to point at that module. So Dagger, SX Dagger at and I give it a version, and it's going to be the branch name, checks. And then I'm going to call my I have a dev function that returns like a playground, basically. I should really call this playground, but it's called dev right now. And then I'm going to open a terminal in that. So same stuff, same general idea from the before, just chaining function calls. Give me the dev container for that module, and then open a terminal in it. I am dreading how long this is going to take, but I did warm the cache, so it should be. But this is, I just want to show you like a real build.
Yeah.
In Dagger, and the fact I run this like countless times every day. I'm a pretty superficial contributor. Like, I'm not contributing to the core because it's pretty intense stuff, but I'll contribute like the higher level features. And I love using Dagger for it. I fully trust the build every time.
That's awesome.
And that's usually not the case for a project of that size, let's just say. I mean, I hope. Come on, you can do it. Let's give it 30 seconds.
No, we got time. Definitely, I can tell it's a little bit lengthier for sure.
Oh yeah, that one loads so much because okay, this builds the engine, which is a common. It has build kit, it has containerd, it has its own container runtime, all bundled into an OCI image with a bunch of plugins. Then there's a CLI. There's 5 SDKs that we build in 5 different languages, and then we bundle them all in the engine.
Okay.
And yeah, so there's a lot going on.
Yeah, there's a lot. That's for sure. But that's awesome. It's good to hear.
Oh, and then it runs it builds it, and then it runs the engine. So it runs an ephemeral instance of the engine, right?
Okay.
And then it runs the CLI in a little playground container, and then it connects the engine as a network dependency, right? So you can orchestrate these things on the fly. And then
is that like manually decided how to orchestrate, or is Dagger doing that based
100% by code? Yeah, 100% by code. So there's an API. There's an API for taking a container and binding it as a service to another container, basically. So here it's doing like, it's actually doing the build. So this is what an actual build looks like with the full context. You can see some UV going on here. That's probably for the Python SDK.
Yep.
So yeah, these builds we run, you can see what's running live here. Okay, come on, I'm rooting for you, builder. I know it's going to work. My only issue is speed.
It's actually helpful, I think, for a full demo to see exactly how this translates for larger projects. I mean, I think this is really valuable for folks to see.
Yeah, these at this size, what happens usually, you run into 3 problems. One is it gets really slow, and I mean this is, I know this is slow in this context, but it's actually not, because we're talking like many minutes, like you know. And okay, now we're done. The second one is it starts being really hard to test and not break because the complexity is just ridiculous. You don't have tests, you don't have types. And then it only runs in one place. Usually it's locked into that CI server. You can't run it locally. Like, you can't do this.
Right.
Okay, I have my playground. So now here's the trace. Everything should have calmed down. The build's done, but some stuff is still running. You can see kind of the stack up there. The yellow stuff is still running. So here you can see that's the terminal running. And here you see that's the actual service running. So like I can see the Dagger engine, so this is Dagger running inside Dagger, just until I exit, and then it all goes away. And it's in there somewhere. Yeah, and I can follow its logs if I want. So that's my little engine, and here that's the terminal that is here.
Wow.
And in here I can run Dagger. Right, so I can go Dagger. No, I have a Dagger within Dagger, and I can see. Okay, there's my little checks feature works. Okay, I guess it doesn't work. Oh no, wait. Well, anyway,
there you go.
Cool. Dagger checks. It's there. Cool. I'm playing around, and this Dagger version is exactly the build from. Like, it's a dev
one that
build
you just finished
from that PR, 100% certain. And when we release a production, like an actual stable build, it will be built exactly the same way with the same version of everything every time. And if you look in the trace, you can see, where is it? Yeah, there's my terminal session running Dagger. And you can see that the trace keeps going. So this is a trace of Dagger running Dagger, and you can see what
exactly
recursively what that Dagger is doing. So here, if I say, give me a container from Alpine and give me a terminal in that, it's going to show me in there. Okay, container from Alpine. There's a terminal. So now we're in a shell inside a container inside Dagger. And
so it's very meta at that point.
Still follow it. Yeah, but that's what integration is. There's always bricks and bricks and bricks. It's always layers and layers. It's always the skyscraper. The question is it duct taped together or is it built out of Lego? Because with Lego you can go pretty high and it's going to hold. If you duct tape, you can't go as high.
You can't go as high, but also you probably wouldn't even be able to audit it, which I think is the interesting thing here too.
Also, yes. Yeah, 100%.
I think that'll become increasingly important over time as well, to be able to audit the entire build. So this is awesome.
Yep. Thanks for...
Yeah, no, this is awesome. Thank you so much. I want to thank the audience as well for joining today. And it's super exciting to kind of run through this in the future of CI and kind of where we can provide context into the development lifecycle. So thank you so much. And any last words for the audience, Solomon?
No, thanks for listening. And if you're in that really niche category of CI nerds, DAG nerds, come say hi in the Discord. We love having visitors, and you don't have to wait until you have an actual use case for Dagger, because usually that depends on work a lot of times. But we love talking about just hearing your ideas and your problems, and just sharing ideas. It's the most fun part.
I love it. Well, thank you so much. Appreciate the time today, and we'll see folks next week at GitHub Universe. So thank you all. Talk to you soon. Take care.
Bye.
Bye all.